David, whose dog?
That's Nicole's dog with the shades.
I love the Zoom pets. That's very cute.
All right, my daughter puts that on every time, and I have to find out how to take it off every single time.
We like it.
Did you see that that lawyer who couldn't turn off his kid's like cat head?
Yeah,
That was great.
I'm not a cat.
yeah. That was funny.
So I have a question.
Yeah.
When we did our breakout rooms and Scott was my client, he talked about having received a mailer.
Yeah, Fred. Yeah, carry on, Katie.
A mailer. There was a card that came that said free solar, and there's been a lot of that kind of stuff.
Yep.
So how do I convince someone to invest rather than lease if they don't want to put the money up front?
Well, it's usually much cheaper. The cheapest way to buy solar is to buy it and pay for it in cash. If you don't have the cash to do it, the second cheapest way to do it is to go to a local bank like a Needham Bank or Wellesley Bank or Webster Bank and get a loan specifically for solar panels. They do this all the time now.
Okay.
And those loans are, they're not subsidized by the state in the way the heat loan is, but they're very low cost. That's the second cheapest way to do it. The third cheapest way to do it, if a client, say, doesn't have the credit score to be able to get a loan, then the third cheapest way to do it is to do the lease. And I don't usually recommend leases because they are expensive. You're paying a lot of money for the loan, basically. But for people who don't have a good enough credit rating to get a loan to buy solar panels and don't have the cash available to buy them up front, then that is the best way to do it.
Thank you.
So who are we waiting for? Cindy?
I'm here.
Oh, sorry, Cindy's there. Karen, then, right? We're waiting for?
And Dorothea, if she's coming.
Dorothea said she'd be here at 8 tonight.
Okay.
Oh, Michael, we're missing Michael if he's planning on coming. I'm not sure he's planning on coming. But
I have a quick question, David. The last time when we covered my house, you said that you would add a solar array for a 25 kilowatt hour solar array to my house. But I also thought at some point you said if you went over 10 kilowatt hour, like if you went over the size of a 10 kilowatt hour array, that there was some sort of, like, it's not good to do that because of something. But I can't remember because of what.
Let's take this piece by piece. So I think what I recommended was a 16 kilowatt array, not a 25.
Oh, you know what? I wasn't going from I was going from, like, we were just talking, right?
Okay.
And I just was jotting notes down.
Okay, all right.
And you were like, oh, are you going to get, like, when you get a vehicle, would you get an electric vehicle? And I said, yeah, well, when mine dies, I would get an electric. So we were just chatting. This was
Okay.
not, this was just, and I was just jotting notes.
Okay, right. So the 16 kilowatt array size will not be sufficient to add an EV. So if you do want to add an EV, I could just calculate that for you, but it's about 3,000 kilowatt hours a year. And roughly in Massachusetts, about 1,000 kilowatt hours a year for every kilowatt of power in the array. So if you go up from 16 to 17, you need to go from 16 to 19 to cover one EV, because that's an extra 3,000 kilowatt hours a year, or about an extra 3 kilowatts on the array size. That's for one EV. If you want to do 2 EVs, you'd add another 3,000. So now it'd be up to 21. So maybe that's sort of where we were getting to on the bigger numbers. But the price breaks are, or the significant breaks are, below 10 kilowatts. Eversource, I think, must approve the system. They have no discretion whatsoever. Above 10 kilowatts, they have discretion. I've never seen them refuse it, but I have seen them cut it back. So one client of mine wanted to put I forget what it was, maybe a 25 or 30 kilowatt system on both sides. He has a long north-south facing house with an east facing roof and a west facing roof, all of which is in clear sun. And by putting the big system on with both sides of the solar panels, Eversource said no, they wouldn't let him go to the full, let's say it was 30 kilowatts, and they restricted it to, I think, 25. Actually, those numbers can't be right. It must have gone for 25, and they restricted it to 15. And in the end, we were able to do a very clever workaround that enabled him to get at least a sort of a 20 kilowatt system in under the limit of the 15 kilowatts that Eversource wanted. But that's like a special case. But the next break is at 25. So, but at 10 and below, they have to approve it. Between 10 and above 25, the smart subsidy drops to 0. So going above 25, you can do it. Eversource won't complain, but it's not really worth it because you're missing out on the entire subsidy. It does not fade out. The entire subsidy drops to 0 when you go to 25,001. So it's 25 kilowatts and 1 extra watt. So the whole subsidy drops to 0. So you really don't want to be over 25. Below 10, they must approve it. Between 10 and 25, they have discretion. And I have seen them push back on bigger arrays. And sometimes it depends on if there's a transformer on your street that's kind of iffy or close to the end of its life, then they may say, no, you can't do it. Or they may cut you back. I've never seen Eversource say no, but I have seen them cut back the size of the request for the array. Does that answer your question, Cindy, or not?
It does. I was madly taking notes when we were talking.
And
All
that's
right.
David, that's based on Eversource's transformer capability and why do they get to cut back and say you can't do 30, you got to do 25?
That's the law, Fred. It's the regulations that manage Eversource. They say they have discretion above 10 kilowatts.
Right.
And it's as broad as that discretion. They can sort of argue against you for a number of reasons. In general, utilities do not like solar power because it's like undermining their business model. They are forced to buy power from you at the retail price of electricity, which is 23 cents per kilowatt hour. They can buy it from a generating station, a wind farm, or a natural gas-fired power station for about 8 cents per kilowatt hour. But they are forced, they're forced by law to pay you 23. So they hate solar panels because it's a money-losing prospect for them. They're paying through the nose to buy your electricity. So they try every way they can to reduce the amount of solar that they're having to subsidize. So that's why if you get into an argument with Eversource, you're probably going to lose it because they do have discretion between 10 kilowatts and 25 kilowatts. And like I said, I've seen them cut back, but I've never seen them say no to a system that someone wants to interconnect.
And they can't say no to a 10 kilowatt or less.
10 and below is automatic.
And what do you think about doing it in stages? So you do maybe 10 on one roof and then 10 on another roof then to play it safe?
Yep, you can do that, particularly if, say, you don't have an EV today, but you might have one in the future, and so you're not sure if you're going to need that extra electricity. The approval for an expansion system is easier than the approval for a new system. So I've never seen them refuse to grant an expansion to an existing array, but I think they have the right to do so. I think if you go above that 10 kilowatt limit on 1 meter, if you've got 2 meters, we have 2 meters at our house. It's a long story, but most people don't. Most people have 1 meter. And if you go above 10 kilowatts on that 1 meter, they probably do have the right to restrict it. But I've never seen that happen. I've never seen Eversource even restrict a application for additional solar panels. But that's not to say they wouldn't do it. I mean, that's right. They do have the right to do that.
How long does it take, if say you are doing a 25 kilowatt array and you have to apply for permission to do that, how long does that process take to get an answer from them?
Usually a few weeks. It's not in a day, it's a few weeks. Right. They really don't like lots of solar panel people connecting to their grid. It's like, it's their property, they own it, and they're responsible for being up or being down. And so they really care about every little solar installation is like a power station on the grid. It's putting
Right.
power into their grid. And when they bring a new natural gas generating power station onto the grid, it's a very lengthy process. I mean, just imagine, I mean, we have 60 hertz electricity in the United States, 60 cycles per second. If one of those power stations is off on its timing and it puts its power into the grid fractionally off, you ruin the whole grid. It's like one power station can ruin the whole grid. So they are very, very strict about how things interconnect, how the amount of harmonic noise they get. There's very, very high restrictions. And then all of a sudden they get 1,000 little solar plants joining the grid with rinky-dink inverters like the size of mine, which is 3 feet tall and 1 feet across. That's not really industrial strength. So it's a whole new world for them to have to cope with these thousands and thousands of little 10 kilowatt suppliers of energy to the grid, and they have to pay you the full retail price of electricity. So it's like it's a pain in the ass for them, and it's very expensive. But they really don't like it. I think Eversource would prefer not to have to deal with all these interconnection agreements, which is why it's such a good value for money. if they're willing to fight it, you can be pretty sure it's very good for you.
What is the harmonic noise that you mentioned? You just sort of mentioned it a little.
So every time you play any music, Cindy, sorry, do you play any music? I know Katie does. She's the funk queen, but do you play music at all?
No, not anymore.
Okay. Well, so just imagine you're sitting at a piano and you hit a middle C. Ding.
Yep.
There are harmonics of the C's higher up the keyboard and lower down the keyboard, all of which play at the same time, because that one string is resonating with those other strings. Same thing happens in electricity. If you have 150 hertz signal going down a wire, there'll be a 100 hertz signal and a 200 hertz signal as well at those harmonics. And those are very bad because they interfere and reduce the amount of power being sent down the line. So Eversource is very careful to make sure that, say, big solar panel plants are exactly in time with very little harmonic distortion. So it's just one of those zillion things that make the paperwork involved of connecting solar panels or any other power station to the grid is pretty significant. It's not, this is why I think in the long term, I think community-oriented solar providers where somebody takes responsibility for building the array, putting it in a field in Western Massachusetts somewhere, 1,000 acres of solar panels, dirt cheap, and then sells you the net metering credits, which you use at a discount off the utility rate. I think that is the long-term way this is all going to go. I think rooftop solar panels are kind of they'll be here for a few years, and then eventually, as the subsidies fade out, it'll be cheaper just to buy your power from a local solar power station. But that's not where we are today. Where we are today is the world of very high subsidies for solar panels and batteries, and very expensive electricity, making it very worthwhile to switch to solar today because of all the subsidies. That makes sense?
Yep.
Okay. So let's carry on. We've got Nicole's house tonight. Now, does everyone have the spreadsheets? I did send them out 2 weeks ago. I just want to make sure everyone's got them.
I couldn't find them. If you want to resend them, that'd be great. Otherwise, I'll just tag along.
Does everyone else have them?
I'm trying to get back into, I do. I'm just trying to get back into my email.
Here, Fred, here's a copy for you.
Oh, thank you, Scott. What if you tell me what date, I can track them down.
It was the email I sent 2 weeks ago. It was after the training session 2 weeks ago. So probably the following day, probably Wednesday, 2 weeks ago is when I sent it, with the attachments, which had, I think, Cindy's, Michael,
In Michael's, yeah.
and Nicole's.
I will find it.
Okay, so let's just dive right in to Nicole's house, And let's just start with with this page, which is the benchmarks. And let's just see what jumps out at you as you look down this list of benchmarks. Now remember, Nicole has a swimming pool, and because we can't determine exactly how much electricity Nicole's swimming pool is using, so I estimated it. I have a swimming pool myself, and so I know roughly how much a pool uses and when it uses it. So I estimated it. I think Nicole and I have been talking offline. I think she's going to have to figure out what the pool is really taking so we can really get accurate numbers on the rest of her house. But for now, it is a good estimate. So these numbers are after I've made an estimate of the pool usage. So you don't need to think about the pool as being a complicating factor here. So just going down these nice blue and red bars, what do you see that jumps out at you?
What were the blue and red bars attached to? Because I just went into,
I didn't
Both
find
the-
them on mine.
I'm sorry.
I
do you-
didn't see that
It was
page.
it was on the back of this page, but I did not get that.
I didn't see the blue.
I
and
didn't
white.
get the page you just showed, David.
Oh, okay. Maybe,
yeah, I don't have it either.
I got this page, but
Okay.
there's nothing on the back.
All right. Well, I'll show you real time then, right? This is this. So the first bar is the total site energy spend. So how much money that Nicole is spending on heating and electricity per square foot. So I've tried to normalize these things. So you're not looking at, is a big house big, is a small house small. These are just per square foot. So you can see the red bar, which is Nicole's house. The blue bar is the benchmark, which is the average for New England houses year round. And you can see Nicole's is quite a bit bigger, maybe what, 15, maybe 20% bigger than the average. So what is that telling you?
That it uses a lot more than the average.
Yeah, this is actually money spent.
So
So
money spent. So it's sorry, I couldn't read it.
yeah, it's okay.
So it costs more to run the home than the average New England home.
Yep, that's right. So let's just keep going. Next one is the carbon footprint, which we actually haven't discussed very much in the last few weeks. We've really been talking mostly about energy cost and the financial aspects, but I do calculate the carbon footprint here, and her carbon footprint is also maybe 30%
Larger than the,
than the benchmark as well. So this is starting to tell me there's opportunity here,
Mhm.
and there's something isn't very good in the Nicole's house. Just be careful. There's no value judgment here. I'm not saying Nicole's house is bad. It's just facts. It just
Looking for the opportunities.
right. Yeah. Look at it from that way. Say there's a lot of money to be saved here, Nicole.
That's what I'm
Yep.
looking at.
Right. So the carbon footprint is pretty high. The next one down is the energy use intensity. And this is a fairly standardized number that people calculate, not just me, but lots of people calculate this number. It's the total amount of energy used usually in BTUs. You can do it in kilowatt hours or in BTUs, divided by the square footage of the house. It's called the energy use intensity. And that's heat and electricity combined, BTUs per square foot per year. This is a number you could actually compare to other people's houses. Some people even publish it. You can see again, that's actually that is a little lower. No, I'm sorry, that's higher too. The red bar is higher than the blue bar. That's this one. Then this one, you've got heating and electricity broken out. So this one is heating, this one is electricity. You can see looking at these, electricity, she's actually more close to the average than heating. So what is that telling you?
That maybe I looked, but I don't remember what it said on her questionnaire now, but maybe she's on oil, and maybe it's just not very efficient. The heat, I'm not even considering the electric right now, but maybe with the heat, maybe she's using oil and it's not very efficient. Like the furnace or the boiler or whatever she has is oil is not very efficient anyway compared to gas.
Yeah, that is true. So a natural gas furnace is typically 90 or 95% efficient. A typical furnace is more like 80 or 85% efficient. So you're absolutely right. If someone is heating with oil, as most of us are, then that is going to lead to a reduction in the the heating efficiency compared to the electricity efficiency. I'm not sure if that is the cause here, but that definitely could be a cause, Cindy, of what's going on here. And then this one with the 4 bars, it's a number that I've sort of invented, which is called green efficiency, which is the energy used per square foot. So it's similar to the energy use intensity, but it's also per heating degree day, which means how cold it is. Now, since we all live in the same towns, this is not a very useful comparison. It's no more useful than the energy use intensity. But if we were on a call here and we're looking at someone who lives in, say, South Carolina, someone who lives in Texas, then you need to adjust for the coldness of the climate. Otherwise, it'd be very, very hard to compare one house to another. But you can see here, the longest bar here is actually my house before the Fab Four. So this very long bar here is my house before the Fab Four, and this short bar is my house after the Fab Four. So you can see the energy used by my house was cut by about 2/3, going from before the Fab Four to afterwards. And Nicole's is almost as high as mine was before the Fab Four. That is not unusual at all. Not at all unusual. I've seen people over here worse than my house was, and some are down here, sort of much better than my house was to start with. But not as good as mine is after the Fab Four. And then draftiness is the last one at the bottom. This is a rougher estimate. These things are quite accurate up here. This one is more of an estimate, but you can see it's way out compared to the average in terms of draftiness. So so just going through those, this sort of gives me, when I look at someone's house, it gives me just a sense of where the problems might be. Is it with the electricity, or is it with the heating? Is it the draftiness, or is it the fuel use? That's one of the causes. So to me, this is part of the overview. This gets me sort of thinking about what are the issues on this person's house, and then so typically I'll look at that first, and then I'll turn to the data entry spreadsheet. Now, did everyone get this?
Yeah.
Yeah. Okay. So let's just go through this then, and just shout out the sort of things that interest you, concern you, make you want to just come back to that later on as you read down through Nicole's data.
Could you throw that up on screen?
I probably can.
Thank you.
Right.
Yeah, but you can't read it right. So let me see if I can share screen.
You know, there's something I noticed here is if you, we know that Michael is pretty efficient with his house. And if you look at Michael's oil consumption, he's burning 0.30 gallons per square foot. And Nicole is burning 0.35 gallons per square foot. So I don't think that that's off by that much. I mean, I think that's probably pretty good for her house. But if you look at her total energy bill, it's $7,750 a year. I figured that based on $2 a gallon. So her electricity, I'm thinking just at first glance, is disproportional in her energy bill. She's spending $5,281 a year on electricity at 22,962 kilowatt hours. Does that strike you as being rather lopsided?
Sorry, I'm not really paying much attention. I'm trying to get Nicole's spreadsheet up on the screen so everyone can see it. Okay, I've got it. Now let me just see if I can share this screen with you.
It just looks to me like she's spending a lot on electricity. I'm wondering why.
So I've shared a couple more things that I forgot to put into this write-up. As I think with me, it's just a process of thinking about things over and over, and more things have occurred to me as after I've completed this form. But one thing I mentioned to David was a year and a half ago, I installed some large storage tanks for water in my basement. And this was because I have a very low flowing well. In the summer will run dry, you know, like we were to the point where I had to make sure that showers and washing was staggered. And if I had to put some water in the pool, it was so difficult. It just wouldn't fill up again. And so my options were put in a new well, or this is what I chose to do, is put in some storage tanks where at night I can slowly let those storage tanks fill up, and they were used for my pool and any water I needed for plants and irrigation. I put in a drip irrigation in some of my beds, and I put in a little bit of sprinkler system, which I didn't have before because I just never had any water, and water to be able to fill up the pool, so that I could use that. I could fill these storage tanks during the night, not be causing a problem with my well during the day, then use my well for my normal stuff during the day, but still have that extra water. And it's worked out really, really well. But I forgot that probably uses a ton of electricity, right? To be running at night all night long and filling up, does that draw on electricity too, to have your pump going?
Let me re-enter the conversation. I cannot share my screen on Zoom because I have to set some preferences in, this is a new computer and I can't do it. And then I tried to email it to you and I don't have Nicole's data input spreadsheet on my desktop. So I just abandon it, right? So we just have to talk it through, I'm afraid. So I just heard you in the background there, Nicole. You were saying you've got your storage tanks that's pumping water into those tanks, and then you're using that to do everything, really, just as your sort of extra water supply, given the constraints you had. And you were just asking, is that using a lot of electricity? What do people think?
I don't think that a well pump, or I don't think that a well pump uses that much electricity. I mean, incrementally, maybe you would have noticed a bump, Nicole, from the time period before you installed the.
It sounds to me like
tanks.
she's added a second pump.
Yeah, there's a second pump.
There's two pumps now.
Yep.
So her well pump is wired so that it fills the tanks. And the second pump is wired so that it fills her expansion tank, which supplies the demand on the house. So I don't know, what would be the power load on that second pump? I wouldn't think it'd be very much, but nevertheless, it's still there.
Also, I was thinking about it. I don't think actually my increase from when I got these storage tanks electricity wise has been that much bigger. So I don't really think that's a huge thing, but that is something new that I did. And then the other factor
Hang on,
is.
slow down, Nicole. So I agree with everyone else's comments that I think the main use of the main use of power in driving the pump for the water is bringing the water up the well. Bring it up 200-300 feet from down below the ground up to house level. The extra circulation around the house is kind of a house level already is not very much. So I'm agreeing with everyone. I think it's unlikely that is the cause of your high electricity usage. It's almost certainly the pool. But because I can't determine what that is exactly, I just estimated it to give us a better sense as to what's going on in your house. But I'm almost certain that the pool, I know from my own experience, pools are real energy hogs. They take a ton of electricity to run the pool circulating pump, regardless of how you're heating it. If you're heating it with propane or heating it with heating oil or heating it with a heat pump, not even heating it. But just circulating the water takes a ton of electricity. And on my house, it was something like a third of all the electricity we were using for the pool and the house combined was for the pool. It was a staggering. I couldn't believe it when I found out how much electricity my pool was using. And that's part of what set me off on this. I'm horrified at how much money I'm spending. I'm horrified at how much energy I'm using, horrified at how much carbon I'm putting into the atmosphere for all of this. I got to do something about it. That's part of what set me off on this journey, was realizing just how much electricity the pool was taking.
So does that circulator pump on the pool run all, I don't own a pool, but does that run all the time?
I think it's half the day, right?
Yeah, so this is one of the main things. I've written a second book called Zero Carbon Pool, about how to cut your pool's carbon footprint to zero, because I did it on mine. And old-fashioned pool pumps, and when old-fashioned, I mean like anything more than 5 years old, is a big pump, and it's on or it's off.
Yeah, but
And-
how much is it? I mean, what, is it on a timer or what?
Yeah, so typically those would run half time. They'd run 12 hours a day, something like that, on full speed. And that is incredibly wasteful of electricity. So I replaced mine with a variable speed motor pump where you can set the speed, and you need to have a certain speed to circulate all the water through the filter, or you'll get bacterial growth. But I set it to the minimum speed necessary to clean the water once a day. And that was 25% of the electricity use of the old one. The huge change. And my old one was it was using like 10,000 or 15,000 kilowatt hours a year. So I cut it from 15,000 to like, I don't know, 3.5 or 4,000. It was a huge cut in electricity usage. So the variable speed motors, and you'll hear about variable speed motors again when we talk about heat pumps, because old-fashioned air conditioners had the same on-off feature. Either it was on or it was off. It was on at high speed or off at no speed. The modern ones have variable speed motors that ramp the speed up and down based on how much cooling you need in the house. And that is a lot more efficient, 4 times as efficient as using the old on-off system. So these days, if a pool is well run, Scott, if it's running continuously at the lowest possible speed.
The one other factor that I think might contribute to my high summer electricity usage, and it is mainly the summer, is our air conditioning is a ducted system that is pretty old, and it's only one zone. And it does do like maybe half of the downstairs, like this room I'm in now is our big family room, which is an addition. And then there's one in the kitchen. And that seems to be, and that's where we are, right, during the day. But yet, all during the day, my upstairs is freezing cold because it's only one zone. So I'm air conditioning the upstairs to a freezing level, and my downstairs, because there's only a couple of vents, it's anyway, it's very wasteful. So I have to fix that system.
Yeah,
And I have some ideas.
And that is probably contributing to it. So let's just hear your ideas, Nicole. And then anyone else. So give them what Nicole.
Well, I think actually, because I looked at this for my own house, they can come in and add zones.
Right.
For your
add zones. I'm going to add a zone so that the upstairs is separate from the downstairs. But also I have to add a few more ducts down from the attic to like the other living room, which doesn't have it, and the dining room, which is open to the kitchen now, but could use a vent. I have found spots in the house where they would go through a closet and not interfere with my second floor, to be able to put one in the dining room and one in that living room. And then I think if that main floor was on one zone separate from the upstairs, that would make a major difference.
Yeah.
I mean, and we, to be fair, to be truthful, we keep it pretty cold in the winter and in the summer. My house is nobody likes to come over because it's freezing here in the winter, but in the summer we keep it pretty freezing. And mainly at one of my children has physical disabilities, and his ability to regulate his temperature is compromised. And so if it gets too hot, it's going to affect him physically. So that's one of the reasons.
Okay, so I'm hearing a few things in what Nicole is saying that are making me think about a different solution for her house. Anyone else getting some similar ideas?
She's got lots of opportunities. I mean,
Yeah.
The boiler's old, the air conditioning's old, the attic insulation is inadequate. The opportunity she just described with better distribution of the air conditioning. Sounds like she has some heat distribution issues too, because the kitchen is cold.
Right.
Yeah. So I tend to agree. I think there's a lot of stuff going on here. And
Dorothea is here.
yeah,
Yes,
Javier,
hi. Sorry for being late, guys. I had an out-of-town visitor.
no worries. So we're just talking about Nicole's house, and she's just talking about the long list of complaints she's got about it's very cold in the wintertime. The distribution of air conditioning in the summertime means the upstairs is freezing while the downstairs is okay. So all those things combined say to me that you're probably better off actually replacing the AC units, which are 15 years old already, with heat pumps, and then adding ductwork from the basement to the ground floor. You can always add ductwork from the attic air handler down through the upper floor, down to the downstairs floor. That's a lot of work. You might be a lot better off just adding some ductwork from below, from the floor below, from the basement, because that ductwork would just be fairly short runs in the basement. It would be inside the thermal envelope, whereas I think you said your attic today is not insulated above the air conditioning unit.
Correct.
So that's also bad, because your air conditioning unit is running in the hottest part of the house, and that ductwork is in the hottest part of the house in the summertime. So it's working really hard just to cool your house down because of where it is. Whereas if you had an insulated attic, it wouldn't get as hot, and the air conditioning unit wouldn't have to work as hard to get the cool air for your house. But I think rather than trying to fix what is not a very good design system in the first place, I think you're probably going to be better off going with a new design and putting a heat pump in the basement and putting some new ductwork in to give you really good air distribution for heating and cooling in the ground floor, and then leave your air conditioning unit in the attic for the upper floor. Because if you start putting ductwork down to the ground floor, you'll need a bigger unit up there. You won't be able to keep everything cold.
She said she was overcooling the second floor, so.
Yeah, so maybe there is enough oomph in it to do everything, but you still got to deal with the attic to bring the air conditioning unit inside the thermal envelope, or you're just wasting tons of energy. You will also, if you do replace it with a heat pump, you will then have problems in the wintertime, because the heat pump in wintertime will create some heat up there when it's in heating mode, and that will melt the ice on your roof and lead to ice dams and water damage. So it's quite often you get these air conditioners in the attic. I've got one at our rental house. You need to be careful of switching them to heat pumps, because it's okay when it's running as an air conditioning unit because it's just cooling. There's no risk of ice dams. But when it becomes a heating unit in the wintertime, it's going to melt the snow. And unless you put insulation on the slope parts of the attic and bring it inside the thermal envelope. So doing that for an AC unit is just good, because you'll improve the efficiency of the AC unit. But for a heat pump, it's essential. Otherwise, you will get icicles and ice dams. This is real. It's happened to people I know, where they've put in heat pumps in the attic in uninsulated space in the attic, or where the insulation was below the heat pump, and all of a sudden they get huge icicles on the outside of the house and ice dams forming as well. So if you do have that situation with a heat pump in the attic, you need to insulate above the heat pump. Otherwise, you'll get these ice dams.
I mean, I have Mass Save coming this Friday, and so, I mean, that's the number one, obviously, thing on my list is ramping up the insulation, which I know is, and then, the more I thought about it, this room I'm in right now is, I think, added to 95, and I can tell between the main house and this addition, like I can feel how freezing it is between the two. So there's something, I don't know if it's because I know it's not properly insulated above here either, but I mean, it's just got some problems.
Is Man Dave coming to your house?
Yeah.
Because I had to do virtual.
No, you can choose. And Cindy and I were saying last week that we both chose to have them come out and just wear masks.
Not for me.
So
That makes a lot-
David, you just sent out a checklist. I haven't had a chance to take a look at it, but I imagine Nicole would benefit by that.
Yeah. Read the checklist, Nicole. And if they're coming out, one of the benefits of having them come out is they can actually feel drafts. You can't feel a draft on FaceTime. So, I mean, the virtual audits are great. It was necessary during COVID, but there's a lot of things they can't feel. And there you go, the checklist. And the way Mass Save works is they will allocate a number of hours to air sealing your attic based off the square footage of the attic. It's just black and white. It's like whatever the square footage is, they'll give you, I don't know what it is, 2 hours per 100 square feet or something of labor time that they'll pay for to have an air sealer seal up your attic for you. So I listed on there other things you can get them, you can try to ask them to do. And this really is an area where you want to be really nice to them, like buy some donuts, buy some coffee and stuff, because these guys want to get in and get out quickly. And they may be able to do your attic in 2 hours and have 2 hours of labor time left over. They'll go and get a cup of coffee if they've got 2 hours off the job. But if you ask them to go and check the sill plate in the basement, the bulkhead door in the basement, they'll probably do it for you. But they don't have to. So that's why you got to be nice to these guys and try to get them on your side.
Nicole, is your basement ceiling finished?
It has a drop ceiling in probably 2/3 of it, but it's not attractive. None of my basement is attractive, to tell you the truth. So my kids use it. Like we have a pool table down there and they play video games. I try to stay away from the basement as much as possible.
Well, the reason I ask is that David just mentioned it. I think you called it the sill plate. Is that what you called it, David?
Yeah.
There's what's called joist pockets that are between the ceiling joists or the floor joists. And if they're uninsulated, there's a lot of return on if you can get that insulated.
Yeah.
But the most effective way of doing that is with spray foam. And I think during this discussion, David, you might have said that Mass Save will not do spray foam. Is that right?
I've never seen them do it, Scott. I'm not saying they won't do it, but the reason they don't want to do it is it's harder to do. And at the end of the day, spray foam is more expensive per R value than fiberglass or blown-in cellulose. They are looking for the quickest return on investment, the quickest bang for the buck, and it just costs them more to put in spray foam than it does to put in fiberglass or cellulose. So usually you'll see them default to those options. I don't know if it's banned from them doing it, but I've never seen them do it.
They do, however, do expanding spray foam in between the sill plate and wherever the sill plate is resting on.
Yeah,
but that's very different than spray foaming insulation.
Yeah.
I had this.
And it really seals. It seals very nicely.
I had this done 3 times in Chicago, and they used a Dow Corning product called Froth Pack, which is a portable system. It has 2 containers in it because there's 2 parts to the foam. So they didn't do the whole truck mounted hose thing. They just use a Froth Pack 600 because joist pockets don't take up a lot of foam.
Right.
And they went around and filled all the joist pockets.
Yeah, well, you can certainly ask for it. And as Fred says, you can do this along the sill plate with just a can of spray foam you buy from Home Depot. And it's quite fine. Just go along and spray along the sill plate, which is where the concrete ends, the concrete of the basement ends, and the wood framing rests on top of it. There's usually a gap between there, the wood warps or something, and you can often feel the breeze coming through there. And just go along there with a can of spray foam and you'll seal it, and that'll be the end of it. Same with holes through the basement wall. I had 2 big holes about this size through the basement through the basement concrete, where you could see the outside through the hole. And so the mice came in and out very nicely through the holes. And I just took a can of spray foam, filled it up, done. Took about 5 seconds. So these things you can do yourself. but try to get Mass Save to do it for you. Yeah.
Question. So on this checklist and like all these things you're talking about, you know, insulation and draft sealing, I got the impression that they don't do this at my appointment, but rather put out an order for it to be done?
Correct. They will not do this on the day they come to do the audit. The audit will determine what they will do for you. And then I'm not sure if they subcontract it or they ask you to contact the contractors. I'm not sure how they do it, but it's contractors who will come to your house who do insulation and air sealing. And that's a separate step. It may be a couple of weeks later when they come back and actually do the insulation work for you.
Those are the guys that I need to give the coffee to and the donuts?
Probably definitely those guys, but it'll be but you really want the Mass Save auditing guy to put down on the list what you want those guys to do when they show up.
Right.
Because technically if it's not on the list, they won't do it.
Right.
Because they're not getting paid for it. So they only get paid for the things the auditor says that you need on your house. And since certainly with the virtual audit, they can't tell where the drafts are, they're unlikely to say this house needs draft sealing. But I'm telling you, Nicole, your house needs draft sealing. So you want to get as much as possible written into the audit so that it gets handed on to the contractors and they do the work for you.
Right.
Well, they'll do a blower door test regardless.
If they're not virtual.
If they're not what?
If they're not virtual. They can't do a blower door test.
No, when the contractor comes to do the work, the first thing they do is they set up the blower door. At least they did with me.
Okay, good.
I had 2 audits done and I've never had the door blower test at all.
Man,
And I was even being told that this was not in the package. My audits were done in 2009 and 2013.
that's
And both
terrible.
times,
Scott, were you talking about the audit when the
They
auditors
totally
came?
did it to me.
You're talking about when the auditors came or when the contractors came?
The contractor.
Yeah, so we're talking past each other. Scott is
Because
saying,
they have to take a before and after reading.
Yeah. Right,
So they set up the first thing they do when they get out of the truck is they set up the blower door. Then they take a reading and then they go around and do a bunch of air sealing. And they're supposed to get it below a certain level. I'm standing there looking at it.
That's not
and
during the audit though.
No, it's
No.
not in the audit. That's when the contractor comes.
Okay.
And the guy didn't want me to see the numbers.
Well, that's interesting because when I had an audit, on the day of the audit, they did a blower test. They did all kinds of sealing and other different things like, you know, thermostats, etc. So it's not, I'm not sure it's always the same.
yeah.
Hi, Michael.
Hi, sorry I'm late. Had something else.
Well, I do agree with what I'm hearing. I do think it's very inconsistent,
yes.
which is why I think the checklist, David, is so important because they're also coming out to my house next week and after. And I like, I'm going to be there with that checklist.
Yep.
Following
it'll
them
help.
around.
It will also, honestly, it'll make you more of a peer with them because most people they meet in their houses, the homeowner has no idea what they're talking about. And the homeowner has no idea what the auditor is doing. But you guys do. You guys have all been trained on this stuff. You know what questions to ask. So so that's another reason to be nice because they're not used to speaking to people who know what they're talking about. So you don't want to come across as like a smart aleck or something. You gotta be nice to them. They're human beings, and but you are very knowledgeable. You guys know much more about this than probably they do, at least in some areas. Certainly, when you start talking about heat pumps and solar panels and stuff, they will know nothing about that. They will only be able to talk about insulation and air sealing. And even that is a big step forward. If you go back 5 years, they never talked about air sealing. They've only added that to their portfolio in the last 3 years or so. And it's just as effective. In fact, in most people's houses, older houses like Nicole's, the air sealing is probably going to save her more money than the insulation. Although your insulation is so bad, Nicole, that may not be right.
Save you more money than anything else.
Yeah, probably.
How much insulation will they give to Nicole? Like if you've said that 20 inches, to bring it up to an R60 is really, ideal. And right now she has, I think, 6 inches of fiberglass. Is that right, Nicole?
Yeah.
So would they, would they bring her to an R60?
Yes,
they
they usually will.
That much?
They will usually just, what they'll do in Nicole's case is probably just blow in cellulose over the top of the fiberglass. So, and they'll bring it up to 20 inches. So I've seen Mass Save do 20 inches routinely on people's houses. So that's one thing they're very comfortable doing, because it's very easy, it's very quick, and it's very simple. They literally have a hose pipe, a giant hose pipe full of shredded newspaper, and some guy stands in your attic with a big long pipe that snakes all the way down to the truck outside, and they stand around and blow it around your attic until it gets to 20 inches. So it's very fast, it's very cheap, and it's very effective.
What goes on the slanted part of the roof?
Nothing. Mass Save will not do that because that requires spray foam, and they won't do spray foam. So they do the easy stuff, which is blowing in. It's also labor intensive to put spray foam in, whereas it's very low labor intensity to blow in the cellulose. So
Well, what if I need to change out my air conditioning unit, which is up there sitting right in that insulation?
they will not deal with that for you. If you need to change out your AC unit and you're going to put a heat pump up there, I mean, actually, even if you put an AC unit to replace your current AC unit, I would recommend putting something in the slope parts of the roof. Otherwise, what happens on a hot summer day is 100 degrees up in your attic, and your air conditioning unit is trying to cool down the rest of your house, but it's sitting in 100-degree heat. So that heat is all leaking into the ducts and into the heat pump itself, so into the AC unit itself. So you really need to bring that AC unit inside the thermal envelope, or you're just wasting electricity.
So I have a question about that. So is your condenser actually up? Isn't it the condenser that creates the coolness, or is it the air handler that creates the coolness?
It's the air handler. The condenser is often referred to as the outdoor unit, and there's some confusion in the terms here, because when you're using an old-fashioned air conditioning unit, the condenser is the outdoor unit. But when you're using a heat pump, which does both ways, it heats in the summer and cools in the winter. Well, half the time it's the condenser unit. It's the condenser unit outside in the summertime, but it's the condenser unit inside in the wintertime. So the terminology gets very kind of mixed up, because heat pumps have started to replace AC units. But with a straight AC unit, the outdoor part is called the condenser. The indoor part is sometimes called the evaporator. But it is the inside part that's...
Cindy, to make it less confusing, the compressor unit would be outside.
You're saying the old style.
New or old, the compressor unit's outside, whether it be a conventional air conditioner or whether it be a heat pump, the compressor unit is outside.
And that's just the compressor unit doing what? Pushing air through?
It's got a compressor with a coil around it and a fan in the middle.
So it's just for the air flow.
No,
It's not creating doesn't have the refrigerant.
No, it's compressing refrigerant, and in air conditioning mode, that's the condenser. And in heat pump mode, that's the evaporator.
so it is producing the hot or cold refrigerant, depending on which season it is and what you want.
The compressor is.
Yeah, the compressor is.
What is the air handler doing?
The air handler has a coil in it that is either cooled or heated, depending on which mode you're in. And it has a fan in it that takes room air, pushes it through that coil, and then back into the room. So in heat pump mode, it would be heating the air. And in air conditioning mode, it would be cooling the air.
Does that make sense to me? You look like...
Yeah, it does. I'm just, I had never heard about, I'm just putting something together now, that's all.
So does it make sense not to have the heat pump and air conditioner in your attic? Because I know, David, you've talked about, oh, if you're going to change your system over, you might as well just make it a heat pump. But now you're saying maybe not having it in the attic?
It's a little bit more work to change an air conditioning unit in the attic to a heat pump than it is to change an air conditioning unit in the basement. So if the air handler unit is in the basement, it's very easy. You take out the old air handler unit in the basement, you put in the new one for the heat pump, you put in the new heat pumps outside to replace the old AC condenser units outside, and you're done. With if the AC unit is in the attic, then you've got one extra step, which is to bring that AC unit, whether it's an AC unit only or AC unit that's now a heat pump, inside the thermal envelope.
Mhm.
You don't need to do if it's in the basement, but you do need to do if it's in the attic, because
Yeah, with extra insulation.
yeah, even if it's just an air conditioning unit, you should do it anyway and insulate the
Yeah.
slope past the roof, because otherwise it's just very inefficient. You're getting a lot of heat in that attic in the summertime, and it's decreasing the performance of the AC unit. But it becomes even more important in the wintertime when you've got a cold attic. That cold attic is now being warmed up by the heat pump in the wintertime. And that heat will melt the snow and lead to icicles and even ice dams that will then have flooding of the water back into the house. So you really don't want it. It's just an efficiency thing on an air conditioning unit, so you just pay more, but it's not going to ruin your house. But if that AC unit in the attic becomes a heat pump in the attic, you risk getting ice dams on your house in the wintertime. So it's really essential that you do it. Insulate the slope parts of the roof. If you put a heat pump in the attic. In your case, Nicole, I would actually suggest you at least consider putting a heat pump in the basement and running ductwork to your ground floor from an air handler in the basement. And then you don't need to insulate your attic, although I think you should anyway, because there's an AC unit up there that's very inefficient. But I think getting that air to distribute into the ground floor, rather than trying to run ducts all the way down from the attic to the first floor. I mean, you can do it, Nicole. And you found closets already that might be chases where you can get the ductwork in there, but get the quotes either way. I wouldn't be surprised if all the labor time is in doing the ductwork.
But I think it only would require 2 more ducts that are pretty easy to come right down from the attic.
All right. So I would just get quotes.
And having all new ductwork coming up from the basement.
Yeah, the only difference would be that ductwork could now be used for heating in the wintertime as well as cooling in the summertime. So now you'd have a forced hot air heating system and an air conditioning system coming through the ductwork. But I would get quotes both ways, Nicole, because you may find the cost of putting the ductwork in is very high compared to the cost of just putting it down through the closet space is very high compared to just putting it up from the basement, which is very easy to do compared to running it down. But yeah, I would get quotes both ways.
Now, is it something like a company like Rodenizer? Would they give me both quotes on both ways?
Yeah. I don't think anyone would. Scott, you're nodding your head. Do you have someone you like to use?
I use Needham Energy to put mine in, but I don't know that I'd recommend them.
That's my current company.
Yeah, I've also used them. They quoted for the Mitsubishi heat pumps at our rental unit, and I did not use them. And I just wasn't comfortable with their technical knowledge. Compared to Rodenizer, for instance, they're very good technical people. They knew what they were doing. I just wasn't confident that the Needham guys really understood what it was they were doing. And I think if you're just using them to put in an AC replacement for an existing unit, they'd be okay. But heat pumps are more complicated. They need more thinking about where in the electrical panel do they go and where in the attic do they go, and is it going to be insulated? So I think you're better off going with a better quality installer if you're going to do heat pumps.
Another question about in the attic.
Yeah.
Could you, if you were putting either a heat pump in the attic without having to insulate the whole attic and make the whole attic conditioned space, could you, I guess, I don't think you need any airflow. Could you just build a box around that? And because you can get Mass Save to insulate your attic free, but then you spend a bunch of money insulating the conditioning the whole space if you do it in the sloped parts. So doing a box is, because you also have to seal your attic. If you're doing the sides, I don't know what most people's attics are, but the style was years ago that you ventilated your attic, like you had eave vents and you have a ridge vent. So you're trying to actually get air circulating up there, and you'd have to seal that all off.
Right, I have vents right now, like openings to the outside.
Yeah.
But that's what they do in Mass Save. In my bid, in the contract, they have these sort of damming things. They have these styrofoam sort of little sheets that they stick in the pitched part, so that basically you could still get ventilation from your eave going into your attic, even when you boost up. I mean, I think that's the biggest part of the labor. And the insulating the attic is actually putting in these little styrofoam wedges
Yep.
in each joist space, right where at the bottom, so that you could still get airflow. Which I guess hopefully I'll still get enough airflow with that. But yeah, no, I was hoping that I could put a box around something in the future if I ever put any sort of heat pump in my attic.
Yeah, so I've never actually seen a heat pump in a box, like a 4 foot by 4 foot by 4 foot cube, but I have seen it where only that part of the attic is insulated. So I think that there may be some need for some air circulation around it. I don't know. But I'm sure the contractors would have an opinion on whether you can actually literally put it in a box, an insulated box, or whether you need to have it in a bigger space, but it doesn't need to be the whole attic. That's then inside the thermal envelope.
Well, what they'll tell you is that the air handler enclosure is insulated, but it's only insulated to an R4 or R5 or something like that.
Right.
Now, if you put a box around an air handler, you have to make it so the service technician can access all the goodies in the air handler.
Sure.
So they're not going to want you to do that.
Well, I mean, it's not very big. I mean, if you had a 4 by 4 box that you could lift up and down.
And then you'd have to box all the ducting.
Well, all the ducting has to be, right. The ducting has to be all heavily insulated. I mean, that's the other thing.
It's the ducting's not any more insulated than the air handler.
Well, no, that's what I'm saying.
4 or 5.
You have to go put on heavy duty stuff. I mean, I assume that you'd have to boost whatever the norm is for any duct work.
Boy, it'd be a lot easier just to spray foam the rafters.
Yeah, I don't know. What does that cost? What does it cost per square foot to do that?
It'd be cheaper than wrapping all your ducting. I think the reason Nicole is asking, she's in kind of a quandary here. I mean, let's say that the basement, it's not feasible to add an air handler to the basement because of low overhead clearance, or there just isn't a place to put it, or what have you. Now Mass Save comes and says, listen, we'll put 12 inches, we'll put a foot of cellulose in your attic. But she would like to put in a solar panel array, and she'd like to go with heat pumps, which is possible for her because her equipment's old. Okay, so now what's she gonna do? She isn't gonna want to add 9 inches of insulation on the floor. She needs to bring the roof, the attic, into the envelope.
Oh yeah, that's the dilemma I face a little bit too, where I'm basically putting off that air conditioning issue till another time and figuring I'll deal with it then. But right, it is. Right.
So I think that's the reason she's asking. I think she knows enough now that she's asking questions about it, but this is complicated stuff. It's not easy.
Oh yeah.
Could Nicole put the heat pump instead of in the attic? Could she set it outside somewhere? I don't know.
You can't put an air handler outside. No.
The air handler needs to be inside.
And David's absolutely right.
You have to use, wait, another question.
The heat pump, just so you know, Cindy, the heat pump
and the air handler, you have both. You have to have the air handler with the heat pump.
They're separate.
Yeah, you need.
They're a team. They work together.
Yep.
Yes.
There are 2 separate units. So
Yeah. No, I understand that there's 2 separate units. I guess when we kept talking about a heat pump, we just always talked about the heat pump. We never mentioned the air handler with the heat pump. So I just imagined a heat pump, no air handler. Got it. All right.
There are both parts. There's an outdoor unit and there's an indoor unit for a heat pump. And so for instance, our house, we have 2 outdoor units and 2 air handlers, one for the upstairs floor, one for the downstairs floor. Okay, let's turn to Nicole's model output stuff, because we've talked about a lot of these issues, but I think this is going to help us decide what she should be focused on doing. So does everyone have this page?
Yep.
Yeah.
Yep. So let's just go through. Just one thing I wanted to point out from the data slide is the data entry is the sun number is 94. That is a very high sun number. That says like immediately, this is going to be cheap electricity. No matter what you decide to do, there's going to be cheap electricity to power it. So that's like that's one thing that jumped out at me when I saw just read through her data. The other thing that jumped out at me is that the AC work is 15 years old. We've talked about this already. It's probably coming up on need to be replaced. Probably a good opportunity to think about putting in a heat pump instead of replacing the AC units with AC units. Although we've talked about the consequences if you want to do that and keep the AC unit in the attic. And you've got two options: put the heat pump in the basement, heat pump air handler in the basement, or put some insulation on the slope parts of the attic. Doesn't have to be spray foam. You can put fiberglass up there. You can even put dense packed cellulose up there. But it's not the blown in stuff. You have to actually kind of pack it in and put a like a netting over it to hold it up in the rafters. Or you can just do fiberglass. Fiberglass is dirt cheap and it's really easy. You just push it up in between the slope parts of the attic. So there's ways to do it that are not expensive, that are very easy to do. That can get you there. Anyway, let's go back to the outputs of the model. So let's just talk about insulation first. So what are your conclusions from seeing what the recommendations are on insulation?
Well, I think definitely insulation for sure. I mean, it's 147% IRR.
Yep.
But I would want to make the decision ahead of time, because I think if Nicole is going to go to heat pumps and she needs to have that space up in the attic as part of the conditioned envelope, then it seems wasteful and difficult to deal with after, to have all that cellulose blown in. And then you're trying to work up there. I don't know, it becomes kind of unmanageable in a way, because then you're having to move all that stuff out of the way, all that cellulose out of the way in order to access what you need to access up there when you do put the heat pump or the air handler in up there. And when you have to seal the sloped parts. So in my mind, I'm just thinking, if it were my house, I'd want to make that decision now. Not now, but before I did any of the other stuff.
Right, before I put the insulation in and what I'm going to do for insulation, I have to decide
The
on the heat
location.
pump and air conditioner. And I think my air conditioner is over 20 years old, actually.
Okay, so what I would recommend, Nicole, is you put down on your list for mass save, saying, will you, mass save, insulate the slope part of my roof? And if you ask for spray foam, they'll say no. But if you ask for fiberglass, they might say yes. So I think that would be the ideal outcome for you, is to get the slope parts of the attic insulated with fiberglass. You've probably got 10-inch deep beams, so that's at least R30. It's not superb, but it's not bad. And they'll probably do it for free. And they'll probably do all the air sealing up there as well, which will really help. And now whatever you do in the future, you've got that either AC unit or heat pump inside the thermal envelope. So I think that's probably the best way through that for you.
Mm-hmm.
Would Mass Save, would they write it up so that they would air seal her roof, the underside of her roof? What would they be air sealing on the underside of her roof? And would they do that?
Yeah, they'll be looking for drafts and then plugging them with spray foam. So typically they'll be going around the edge of the roof where the slope parts of the roof meet the floor. There's often a lot of gaps and cracks there. There are also a lot of gaps and cracks around. Do you have any canned lights, like recessed lights in the ceiling of the upper floor?
No, I don't think recessed. I think I have a light bulb hanging.
Hanging down, okay.
Oh,
so
you mean like on the second floor or in the attic?
on the second floor, like going up into the ceiling of the second floor, so they're up into the attic.
Yeah, I think I have some semi-flush ones that they had to come through the attic to put in.
Okay, so usually what you'll find is those are unfinished on the upper side. So there's drafts coming through those light fixtures. That's a big source of drafts into your attic, because remember, the stack effect creates pressure at the top of the house and it draws air into the bottom. So you have a lot of air flowing up your house like it's a chimney, and that will come through those light fixtures and up the stairs and through the attic access hatch and through any gaps and cracks between the walls and the ceiling. So that's on my list. that's one thing you should ask them about. You'll probably find if you look at your plywood, if you're in the attic looking down the plywood, there's probably holes cut in it in places. Right, those are the places they'll be doing the air sealing to try to create a tight layer on top of the house so that stack effect is stopped. Because that stack effect, all that air going out has to be chilled down again with new air coming in the summertime, or has to be heated up with new cold air coming in the wintertime. So that's why air sealing is so effective, because every time air leaves your house, you have to heat it up or cool it down when the air comes in from the outside.
What about those like vents that are in the corners of where the eaves meet? I mean, that's just like open air, and you're not sealing that up, right?
Well, you only need to seal it in one place. If you seal the floor, then the air is not getting up into your attic, and it doesn't matter what happens through that eave vent. However, your current situation is you've got a lot of air coming up through your house, gets into your attic, and goes straight out those eave vents. There's nothing to stop your air and trap it inside the house.
Right.
So you could either seal the upper part of the attic or seal the floor of the attic. You don't need to do both. So that's where the mass save contractors will come in, and they'll just figure out where the drafts are and seal them. So that's one place where I think they're reasonably good. I wouldn't say they're great, but they're reasonably good. You'll almost certainly see a big reduction in your draftiness, and therefore your heating bill, when they've done the air sealing for you.
And again, that air sealing is done not at the audit. They'll just identify that it needs to be done.
Correct.
Okay.
Correct. They'll appoint one of their many mass save contractors to come to your house, and then the contractor will follow the audit list written by the mass save auditor.
Okay.
Do you think that if you were trying to condition, basically do the roof, the sloped roof, so that the attic is conditioned, that the fiberglass, I guess, is only going to be right? They probably only have 2 by 12, so you're only going to get 11 inches or so of fiberglass. What about the option of seeing whether they would put on top, if they put in the fiberglass, whether they put in like 2-inch rigid board underneath the roof joists?
It's worth asking for, Nicole. But do you see what Michael's getting at?
Yep.
Because I'm just suddenly trying to rethink my design. So when I'm playing around
I
with it.
actually think the design Michael's got the idea for is a very good one, where you fill the planks that make the slope part of your roof are typically 10 inches deep and 2 inches wide, and the gap between them is usually 15 inches. You can just buy at Home Depot insulation that is 10 inches deep and 16 inches wide. So when you push it, it just compresses slightly, and it just squeezes in and holds itself up there by friction. That's very easy to do. That's what mass save would do. But that's 10 inches times R3 per inch. That's only R30. The recommendation is more like R50 or R60. If you just tack on or nail on a 2-inch ISO board, to SR5 per inch as R10, you added R10 to, you've gone from R30 to R40. Now, I'm sure they wouldn't.
Moisture, I guess. Then there's those people, I suddenly remember that there's this whole problem of whether you create a sort of a point of condensation with that kind of stuff, that might be a problem with that design, is that you might get a point where you might actually get some moisture accumulating behind there. I'm trying to think of that's a concern to worry about with that sort of design.
So I'll just tell you. So I'm doing something similar on our rental house, because it has an upstairs space which is completely unfinished today. So it needs everything done to it. So we're going to be putting actually dense packed cellulose into the rafter bays, and then we're going to be putting a membrane. It's it looks like a sheet of paper, but it's not paper. It's a type of plastic, but it's not like polythene. It's not like a watertight plastic. It's a breathable membrane, like Gore-Tex is a breathable membrane for jackets, for rain jackets and things. It's a breathable membrane that allows any moisture behind to dry to the inside. So that is like that is beyond code. You do not need to do that to meet the current building code, but that is sort of best practice today. And then we're going to put a Roxul board, not ISO board, but a similar kind of insulation board on the interior of that membrane. So that is sort of what I just described is probably the best practice today for insulating an attic. You fill the rafter bays with something dense packed cellulose or fiberglass. You put a membrane on the inside of that, which is airtight. The membrane is like rolled up like I don't know, like a roller blind or something onto the rafters and stapled in place. And then the joints are taped over. So the joints, so there's an airtight seal on the slope part of the roof, and then it's glued down to the plywood on the floor. So it's intended to be an airtight membrane, but it's a breathable membrane like a Gore-Tex jacket. It's not a a sheet of polythene that wouldn't breathe at all. Because
David, just a question. When I did that myself downstairs, where I basically had the fiberglass insulation and put a membrane so that the fiber would just not disintegrate. This is not adding an R value at all, right? The membrane that you're adding. I mean, this is a breathable, thin sheet, right?
There's no R value to it. It's purely for moisture control.
Exactly, for moisture control.
That was what you added, Dorothy. Was it like a mesh net where you could see holes?
More like a landscape fabric, like a dark black landscape fabric, and it seemed like the way to go. And it keeps the fiberglass up, and it looks reasonably okay. But I felt like I wanted to just cover it up a little bit because the fiberglass oftentimes catches dust and it becomes really gritty at a point and brittle.
Yeah, so I think what Dorothy just described is an older generation membrane that does allow some air passage through it, but it's not a moisture control membrane. The membranes I just described are fairly new. They all come from Europe. They're none made in the United States. The ones we're buying are made in Germany. There's another manufacturer in Sweden, in Switzerland that makes them. They are pretty high-tech products. If you've seen the outside of houses under construction, they'll often put Tyvek wrap on the outside. That's the same kind of idea, but it's an older generation product. The newer generation products are designed specifically for what I just described, which is attics or cathedral ceilings where you have a problem with moisture management. If the moisture gets across that drywall or into the space behind the drywall, it's going to condense on the cold roof surface in wintertime. And so you really want to keep that moisture inside the house and don't let it get outside the house onto the cold roof. But you still need that space to dry. You can't just put up polythene there, which would stop any moisture getting up there, because now any moisture that does get behind there can't dry out. And then you get rotten timbers and you get asthma and mold and all kinds of stuff. So that's why these new fabrics have been created that are like Gore-Tex, because they allow moisture to humidity to breathe through the membrane, but they stop in one direction, but they stop it in the other direction. So when you wear a Gore-Tex jacket, it's waterproof, right? It's waterproof. You don't get any rainwater coming in, but you can still sweat and allow the humidity to escape. It's a one-way membrane. But if I assure you, Nicole, well, I don't assure you, I very much doubt the mass save contractors will know what you're talking about. Because what I just described is so far beyond code, it's like alien to most people. There are very few people who know how to install these membranes. I'm buying mine from a supplier called Building 475, who is sort of the best. They're the best like eco products, technologically advanced products for insulation and air sealing. They're based in Connecticut. They have excellent support staff. If you want to talk to them about what do I need for my house, they're very technically knowledgeable about all this.
It's a great shop. If I may interject, my architect friend buys from them, and she's from Germany too. She gets triple glazed windows at the 475. It's the shop where most architects go who do passive house, and highly recommended.
What was the name of this again?
Building 475. It's in Connecticut somewhere. Just Google it, you'll find it. Building 475. They really have like these. They're the only supplier I know of these German-made membranes.
Yeah.
And I don't think they have the Swiss one, but somebody else has the Swiss one. But there really are only two of these membranes in the world, and you've really got to be sort of a heating HVAC insulation guru to even know these things exist.
So you're using dense packed cellulose
In the rafter bay.
in the rafter bays, and
Yep.
then you're putting this membrane over the top of that.
Yeah, the membrane will just be tacked to the
Right.
rafters.
Right,
And
and
then
then
but-
what, and then did you say isoboard goes over that?
No, I personally don't like isoboard because it can burn and it burns with a thick, black, toxic smoke. So I just don't like the stuff. But I'm going to use a Roxol board, which is a rock wool board, which is about the same R value, but it's more like a compressed fiberglass. It cannot burn. It's completely inflammable. So I
And
just
that, and that would not defeat the purpose of the membrane?
no. In fact, the membranes are best installed with a layer of insulation on the inside. That's about 1/3 of the total insulation and 2/3 is on the outside.
So the membrane is on the outside.
The membrane is sandwiched between the Roxol, which is, so if I'm standing inside the attic, I'll be looking at the Roxol board.
Okay,
Then behind that is the Intello membrane that's tacked onto the rafters. And then between the Intello membrane and the plywood of the roof is 10 inches of dense packed cellulose.
I guess part of why that works is you're
Okay.
using the dense packed cellulose. I'm a little concerned with if you did fiberglass that you'd have too much air where you could still have moisture and condensation. That I think, I mean, I don't know enough for sure, but any of these kind of designs, I think would probably be better with something that basically doesn't leave any airspace there, like the dense packed cellulose. With
like foam.
fiberglass might and foam. Whereas, because even with foam, they have issues of wet, closed cell and open cell, but for
Oh,
moisture.
so,
But yeah, no, I think that the fiberglass in that setup would probably be a little risky for moisture issues. But I'm
Yeah,
not-
so remember the Intello membranes are breathable.
And I'm saying, but also, I guess, breathable through the rock for the fiber or whatever they are, rock wool.
Yeah, the rock wool is also breathable. It's like a kind of a compressed fiberglass. So
Yeah.
that structure is actually what was recommended to me by the guys at Building 475. So that's I think that's about sort of best practices. Okay, we've only got 10 minutes left, and we've so
And how
far.
much is that going to cost you per square foot?
I haven't got the quote yet. I'll let you know.
I know, I'm trying to figure out how that compares to just doing the blown in. Foam.
Yeah, my issue is similar to Nicole's. I have an air conditioning unit up there.
No, I'm just talking about versus just doing a spray foam and without all that stuff.
or faced fiberglass.
Well, that's a lot cheaper, but I'm saying, let's say you compare it to something a little better than that, like just a good closed, a good blown in foam. I'm just curious whether, but you can tell me later.
Yeah, I'll find out. But as I said, I have other issues with spray foam that are not to do with its insulation value. I don't like its flammability. I also don't like its end of life disposal issues. You cannot separate it from the wood. It is glued together. Whereas all the materials I've described can be easily separated and disposed of properly at the end of the life of the building. So there's a lot of other issues I have with spray.
I appreciate that you do those kind of things. That's part of why I didn't do certain things in my house is that.
Right.
But yeah, go on.
Anyway, let's keep going because we've got like 5 minutes left. I do want to talk about a couple of things at the end. And so far we've got through insulation on Nicole's house. Let's talk the heat pump. So what do you think about the heat pumps here?
I think if Nicole's gonna do solar array, then the heat pumps look like
Absolutely.
a good deal to do. If she's replacing her, well, if she's just gonna leave her furnace where it is, or boiler where it is, she can leave that as the backup and replace, with the heat pump for the AC and use the heat if she has the solar array. But
Yeah,
only if she's going to do the solar array. Otherwise, the numbers didn't look very good.
yeah, and so you can start to see how these things fit together, right?
Oh, yeah.
You really got to do all these things like a 3D puzzle. You got to get all the pieces to fit together. And this is where all the contractors fail, because all the contractors will tell you, well, I'm an HVAC contractor, you need heat pumps, without thinking about the insulation, without thinking about windows, without thinking about the solar panel array. Nicole's lucky, you got a very sunny exposure. You could do it on the roof of your house. I know you've talked about doing it in a ground-mounted solar array. So you can generate as much electricity as you want, Nicole. So in which case, I would go all in. I would do the heat
Exactly.
pump. I would do the heat pump or water tank. I would think about electric vehicles for the future because you're going to have cheap solar power. So why not go to town, get an induction stove? I mean, you don't need to do all this
Yes.
today.
Ooh, I
Maybe,
have an induction stove.
right, okay.
You
Good.
can test drive my electric car, Nicole. You can test drive it. I'm
Good.
all for it. So when I was looking at your 22,000 kilowatt hours, my head was spinning. I was like, this woman needs to get solar as big as it could be. And
She needs to reduce her electric footprint is what she
oh
needs to do.
yes,
That's the pool, Dorothea. You missed the early part of this conversation. Nicole has a swimming pool.
oh, okay, that's what
And-
it is.
Yeah, so in the numbers on the benchmark comparisons, I made an allowance for the pool. I took it out, but
Okay.
but Nicole, you are using 22,000 kilowatt hours. That you're using that. So I think, given you've got a great sunny location, you should go all in, have enough power to power the pool, the electric vehicles, the heat pumps. I mean, everything should be electric in your house because you have a great solar location. You're going to get dirt cheap electricity.
David, when you were working up Nicole's thing, did you consider a mini split?
For the addition,
Well, she's got a big family room there that may lend itself well to a ductless system. Anyway,
Yeah.
just an idea.
No, I think Scott's onto something here. I think when you get to that point, Nicole, you've got a lot of different options with your house. You could do what I said, the air handler in the basement, and put ductwork up from the basement into the ground floor. You could also do what you were talking about, running the AC ducts down from the attic to the ground floor. You could also do what Scott is suggesting, put a mini split unit in for maybe some of the rooms on the ground floor. So you've got lots of options here. The way my modeling work, it's not so particular as to say you need a mini split. It just looks at the energy consumption and what having a heat pump would do compared to having a gas furnace or an existing AC unit. So, but these kind of options, Nicole, I think you should be raising these with whoever you call to do the HVAC work.
And also this family room that I'm in is attached to a garage. It's a 2-bay garage, but it's 2 cars deep. So it's very large garage that the upstairs is unfinished that we are going to turn into an apartment. And the roof of that is connected to the roof of this family room. And I'll probably end up, if we're all in on the solar, then I'll probably putting mini splits up there.
Yep.
And maybe even point one in here because it's all going to be right near this this room.
Yeah, so I think these are very good questions to discuss with the contractor. I think what we can do as coaches, and certainly what I can do from the modeling point of view, is get you to that point to say a heat pump is going to really add value for you. It's going to save you money, save you a lot of carbon footprint, particularly when you pair it with solar and you do the insulating and the air sealing as well. But when you get to do you want mini splits? Do you want them here? Do you want them there? Do you want them in the basement? Do you want them in the attic? That's why we need coaches, because there's a limit to how much you can do in software. Right? At some point, you've got to say, well, how do you live in this space? Which rooms do you use? Do you leave the doors open? Do you mind having them connected? Do you like the look of these things? You're into territory that can't be done without a human being like you guys being the coach and working with the homeowner to make those decisions. Okay, I think we've got to lead us a little bit, only because I want to finish up with a couple of questions. So let me just ask: do you think you feel ready now to be assessed, or do you still want to carry on? I'm totally okay with carrying on if you want to keep doing through more examples, more case studies. I don't mind, whatever you want.
Can you talk about how the assessment's going to work?
Yeah, it's going to be very simple. I'm going to get, I think, 5 people, the next 5 coaches who want to start in the second round. I've got 5 people already have asked me, and I'm going to have them join a Zoom call like this, and each of you in turn will present your recommendations. Nicole, it would be on Actually, it would be so. Who's your? If you're the client, Nicole, who is your coach?
Scott.
Scott. Okay, so Scott would be presenting his plan to Nicole with everyone else listening in, and then at the end of it, everyone will ask questions, and then secretly I'll ask them all to vote, and the vote is simply yes or no. Do they feel confident in your recommendations, Scott? Do they feel confident in your advice? Sorry, not your recommendations, in your advice. That's it. That's all. And then if they say yes, then you'll get a nice gold sticker saying Scott Decker is a zero carbon trained and certified coach.
As long as it says David Green on the card.
So that's it's my intention is to make the assessment very real. It's not me. I'm not your assessor. I'm not going to be questioning you on the intricacies of heat pumps or how the second law of thermodynamics works. It's not a quiz. This is not high school. This is intended to be, can you give reasonable advice to someone who's a homeowner in Sherburne?
Who is seeking you out as a volunteer, right?
Exactly. Yeah.
They
Exactly.
want your help.
That's
But
exactly right. Yeah. So that's the only test that I think is reasonable. I don't think it's a low standard. I think it's quite a high standard. But I don't want you guys to be being assessed unless you feel yourselves confident of going there. And I'm just want to check in with you, but I think these case studies seem to have been very productive. Is that sort of the right feeling?
Absolutely.
I think they're helpful, but we would meet with the client. If I'm not mistaken, I think some clients would need help filling out the assessment form, and then it goes to you, and then we meet with them again. Correct?
Yeah, it's probably several times. I'm guessing it's going to be, what I've found is some clients they're in a high need of hand-holding. It's not that they're not smart, they can't figure it out. They can measure their own house, but they actually need to be stepped through it step by step. They can all get there, but sometimes it takes more hand-holding than with others. Some people are very, very happy. They know exactly what windows they've got. They know exactly what insulation they've got. Some people, you've got to work at it. It's not obvious first time around. Karen's house, for instance, she filled out her questionnaire, and when I ran the model, my model was saying that she should be using half the amount of heating fuel she's using. So I went back and said, have I got this wrong? Did I misunderstand something? And then we went through, well, what is the insulation in the basement? What is the, and then she sort of said, well, it's not quite as good as what I said it was. So it's like, okay, so it took a process to get to actually what insulation she really had. That's been true with some of you, not true with others. So I think you're going to find there's a variety of clients out there. Some are going to be, yeah, here it is. Here's the spreadsheet. Bam, here's the results. But some people are going to really have to be stepped through the process of figuring out what it is. Because for a lot of people, this is alien. It's alien territory.
Right. I think for a lot of you, like Scott and Michael and Dorothea and even Katie with her solar panels, I mean, you guys are so much more educated than the normal person who would, like me, like, you know, this has just been so eye-opening, but you guys really know what's going on. So I need
Dorothea shaking her head.
No, I'm honestly, I mean, I have learned a lot in the last couple of weeks and so, and I'm still, I think, personally, I think coaches don't need to have an answer for everything, right?
Right.
You could also be very competently saying, let me get back to David and find out.
Yep.
But I mean, we all know about the R60s. I mean, how you can reach certain insulation. We have to learn this a little bit. And when it comes to the mechanical systems, I think watching a couple of videos is really, I have to sometimes watch it over and over again to really get it. And for me, it's also terminology. I really have to memorize the terminology. I can explain this in German, but not in English. So Mass Safe has a couple of really good videos on how a heat pump works. Sitting down with your client and watching it together would help, right? You could explain, this is how this works, condenser outside, or excuse me, compressor outside, condenser inside. things like that. I think make it, you don't have to have an answer for everything. It's just the process that needs to be, I think, pulling all the data together and that David then can work with is going to be your actual work. And then finding the solutions to it, you always, I think, David, you're open to really walk, the coaches through the consultation if they are not 100% sure, for example, about where could the air source heat pump go in the attic or in the basement and things like that. I think it's going to be a process where you first pull together the data, David's going to produce the energy model, and then the actual consulting begins with constant feedbacks with David, if I'm correct on that, or
yeah, the constant feedback with David probably isn't going to work if there's, I mean, there's 6 of you right now, there's another 6 want to get trained. So
yeah,
I really want you guys to be the primary consultants to the clients, not me. But we got to get there, and we're not going to get there overnight. So what I would recommend is you work through the issues with the client as best you can. But if you're not certain about something, if you're not comfortable, please email me. I don't want you feeling uncomfortable making recommendations to people. I think the recommendations coming out of the software. So what I've been giving you is blank versions, right? My actual versions come with written recommendations on them. But so you'll be getting that, and then you'll need to interpret that for the client situation and their house and their budget and their willingness to do stuff and answer all their questions. But if you've got questions, please ask me. I can't consult to everyone, but there's only one of me, right? I can't consult to everyone, but I don't want you guys not feeling comfortable making recommendations to homeowners.
I got a question.
Yeah, Scott.
How is the Sherburne Carbon Committee going to package this in the effort to get homeowners to use this client service?
Oh, I have a good answer for that. So I think if I get the answer correct, Scott, is how are we going to advertise the Energy Coach initiative, right? So I'm currently building a website where where this kind of like initiative will be featured, and I will also do a news on a regular basis where we're going to talk about that with David's email in there. So we're going to funnel people through David, and David is then basically connecting potential interested homeowners with you guys based on your availability and bandwidth.
We have any idea what the timetable is?
I guess the first cohort is fairly soon trained. It depends on
So are we
when
hoping
you
for
guys,
June, July, something in
maybe even
May?
earlier.
I think it's as soon as you guys are ready.
Exactly.
I don't think we'll have any difficulty getting the word out. Even just putting something up on Nextdoor Sherburne will probably get enough people to raise their hands. I think we recruited all of you through just a single post on Nextdoor Sherburne. That was it. It wasn't like a comprehensive effort to get emails and stuff in the post office windows and in the Dover Sherburne press. So I don't think we'll have any difficulty finding clients for you. I think we'll be overwhelmed with clients, to be completely honest, and we'll have to manage the process with them, which is why I'm keen to get onto the next cohort of coaches. I think 6 is not going to be enough. I think we're going to need more like 15, something like that. But we just don't know. We just have to try it and see. Anyway, but I need you guys to give me some feedback. So do you want to carry on and do another session next week with another case study?
If it's at the cost of you being able to train more coaches faster, I don't have to go through another case study, but I want to understand this. So the client reaches out to you, and you assign a coach. Coach meets with the client, helps the client fill out that assessment of their home. That goes to you. You crunch it and send it back to the coach, and the coach then meets with the client and goes over that.
Yep, that's exactly right. And
Okay.
I suspect that will happen. That will probably have multiple meetings. It won't be just one meeting. Get
Right.
there. You'll probably have some back and forth. Did you mean
Mhm.
this? You sure that was that feet or was that inches? You know, there'll be some back and forth. And then when you get the results, you'll be back and forth with them. This is too much for most people to take in at one sitting. You know, you're probably gonna have to take them through it over multiple meetings. Remember, going back to the coaching stuff with Fred, you probably got to get the husband and the wife in the room. And if they're adult kids, you may want to think about getting them in the room too. But it's not going to be unlikely to be one person. You're probably going to have more than one person in the room to get those stakeholders involved.
There's also, don't forget in there is a mass save audit.
Yeah, and you got to get a mass save audit done. So
That's
it's
one
not
thing.
it's not like bang, bang, bang. I think it's going to be a process that plays out probably over a couple of months.
Okay.
Until you get someone to the point where they're like, okay, yeah, this is a good program. I understand that. Makes sense. I think we'll do this year, and then maybe we'll, we'll wait till the end of the year. We'll see what the heating bills are like. It's going to be a process. It's not going to be here you are, go, done. It's never been that way with any of the clients I've been with. It's been a back and forth process over usually several months. Okay, so Katie would say we can stop here. What about other people?
I think I'm in the same boat as Katie.
Okay, Scott?
I'm willing to go on and learn more. I mean, the question is whether or not we keep on with this Tuesday training session or stop it. Is that?
Yes, that's exactly right. Do you want to carry on doing case studies for another week or so? At some point, we have to say, okay, let's do the assessment and see whether you guys are ready to go and start helping homeowners.
Well, I don't think it'd be bad to do the assessment. That would give us kind of a baseline to see where we all are.
Okay.
And how confident are we? And then whatever we trip over, we can strengthen.
Mm-hmm.
Yeah. Okay, that's a good approach. Nicole, what do you
It
think?
doesn't have to be one or the other. We can continue.
Correct.
We can continue to learn as we're actually coaching people, and that might be a really powerful way of doing it. Look, I have this homeowner. Here's what we're up against. What do y'all think? And that could be useful, just as useful as working with Nicole's house.
Well, we're going to have some mass save experiences here too that can be brought to the table.
Yeah.
Yeah. So what I'm imagining is after we're done and you guys all start working with clients, is you may want to continue having like once a week meetings like this with all of you guys getting together, so you can share your experiences, and maybe somebody's got a different idea for how to do it, and so that way you'll all continue learning from each other. And maybe occasionally I can be part of it too. I'm not trying to like kick you guys out of the nest. I want you to be successful, but I also can't afford to be holding your hands forever. That's the time which you guys take over the bulk of the work, and you sort of over time, over 3, 4, 5 clients, you're ready to fly on your own. So that's what I'm hoping to get to. So yeah, Nicole.
It's just now that I've been talking to solar array companies, and I'm getting proposals in, and they're all, different size systems, and they're different levels of, the panels, and then the different inverters, and there's string inverters and micro inverters and stuff like that. I mean, how far do we take people as coaches? Because this stuff is like, I spent a lot of time on the phone today talking to each of them about the different proposals, and I don't know how I'm trying to evaluate the differences between them. It gets very confusing. And is that something that we're going to be doing with clients as well, like bringing them through? Or the question of whether your heat pump goes in the basement or the attic. I mean, is there some point where we just say, okay, now you're dealing with Roadenizer and make your decisions, and now you're dealing with the solar companies, make your own decisions? Or do we coach people through all that stuff too?
Well, there's no hard and fast rule, Nicole. I've found with my consulting work, some people want to stop at I'll hire the contractors, I'll take it from here. Other people actually want me to go through every bid from a solar panel company, solar installer for them, which I don't really like doing. It's like not what I signed up to do, but I try to help people get it done. I'm not trying to do this and say, bye, you're on your own. I want people to get this done. So I tend to take the view of whatever the client needs, I'll try to help them get through that without it taking endless amounts of my time. I'm not trying to do everything for them, but if the client doesn't do anything, we have all failed. It's all been a waste of time.
Right.
So I try to help them as much as they need help until they can get something done. And I find there's a huge spectrum there. Some people are very willing, once they get my recommendation, like, okay, I got it. I'll call this guy to do the windows. I'll call this guy to do the installation. I'm done. Thanks very much. Other people are like, I got these 3 bids and I've got no idea what they're talking about. And you know, they need some help, or they're not going to make that decision without someone to walk through it with them. So I've found it's all over the place, Nicole. I just try to help people get the result.
I have to go.
Okay, so
What
let me suggest we try to set up for next week. And I don't have the assessors ready and waiting, so I'm going to have to recruit them. But let's set it up for the assessment next week, and let's see how it goes. And if we're not confident, if they're not confident in you, you're not confident, then we'll just carry on with the training. I have no problem with that. This is not high school. It's not like this is a graduation requirement or something, or an MCAS high stakes test. I want you guys to succeed.
Thank you.
That's good.
Succeed. So
Sorry?
I'll hear from you. Bye.
Okay.
So do we prepare, like, would I prepare to present Scott's information?
Yes, exactly. So each of you should be, I'll write something up so we're clear on it, because I haven't been very clear on it so far. But yes, each of you as the coach should be presenting to everyone on the Zoom, which is going to be everyone here, plus probably 5 other citizens of Dover and Sherburne. You're going to be presenting to, as though Scott is your client, you're presenting to him, but everyone else is listening in.
Right.
And then there's going to be questions and answers. Maybe Scott will be asking you questions. We may all be asking you questions, and the assessors may be asking you questions. And then they get to do a secret vote on whether they feel confident in your recommendations.
And will we be getting like Scott's and Dorothea's and everybody else's information that we haven't received yet? Karen's as well, I suppose.
If you want it, sure. I was actually planning on just keeping it back only because if we do decide to carry on with more case studies, then I'll go into each one of those in turn, rather than distributing it now. Because the way I've been trying to teach this is giving you blank versions of the energy model outputs. In reality, those come with some recommendations already built in.
Right.
But I didn't want to like prejudice the discussion. I wanted to have the discussion without the recommendations. So you'll get more information in reality than what you've got for these case studies.
Yeah, that's fine.
Okay, so let me set that up for next week then, and I will send you a sort of an overview of how we're going to run it for next week, and we'll see how it goes. I mean, let's remember this is the first time we've done this, an experimental program, and we'll just take it as it comes, and we'll read and react, take it from there.
Cool.
Makes sense. Okay.
Okay.
Sounds good.
Thumbs up.
Thank you.
Very good.
Tom, see you
Good night,
next.
everybody.
Good night.
All right. Bye,
Good
everybody.
night.
Bye-bye.